I've got Google Colab here. All I did was log into a Google account and start it. Now, by the way, here, this is going to automatically help you write your code with AI now, which is kind of fun. But anyway, you got an environment here. I should mention, by the way, you have not only Python, you have Bash. You can do Bash with an exclamation point, like IPA, and run that. It's provisioning me a container. There we are. So you can run Bash commands with an exclamation point, or you can run Python without an exclamation point. And you can keep putting code in the same box here, or you can just keep making more and more boxes of code and run them one by one. So the first one is print hi. That's hello world in Python. And there it is, it prints stuff. And for all this workshop, it doesn't matter what version of Python you have. All right, so let me demonstrate some stuff here from this one. All right, so you very often have to manipulate text. So Python makes this pretty easy. You can find a string, which is quotes. By the way, let me, all right, folks, why don't you pipe down a bit so the people near you can hear me. The one thing important to learn, which was real hard for me to learn, I came from C and Fortran, and in C, a string is a series of bytes, and each character is one byte, which, by the way, makes no sense at all, because only 127 possible values out of the 256 are used for characters, and that only does English. And these days we got Chinese and Arabic and everything, so the proper thing, in Python 3, a string is a series of characters, and each character is a Unicode object that can be up to 4 bytes long. That is the right way to do strings. It took me a long time to get used to that. Anyway, so here's a string, hello world, and you can define it this way and print it. Then you can just use square brackets to pick out parsers of it. This is 0 up to but not including the third character, third to sixth, 3 from the end to the end. Various ways to cut a string apart. That's going to be quite useful. Now the next thing you might want to do is networking, and you're going to need to do this because a lot of the challenges involve connecting with my server on the internet to get stuff to work with. So here is a simple thing that is going to connect to my server. So this is what's called raw sockets. This is what started it all. Back in the early days, for example, Microsoft MS-DOS didn't hardly do any networking except local networking. And Microsoft used some horrible mess called NetBIOS, and Apple had their own thing called AppleTalk, and they were only for local area networks. And then the internet came out from Berkeley, and Berkeley defined Berkeley standard sockets, and that's how the internet works. And raw sockets are available in every language. They're the fundamental way you use the internet. This is not that common anymore. Most people use higher order libraries that do more, but this is how you make raw sockets. You import the socket library, you then create a socket object named S, then you connect to a server on a port. That does the SYN/SYN-ACK, if you know your Net Plus, and that connects. Then you can print whatever comes back, what is received with this command, and then you can send anything here and print what comes back up there. So this will print the prompt if there is one, then send something. And so this prompt says, what have you to say? You send it something, and it will echo it back saying you said that. That's all this is. This process, which is, by the way, a Python script on my server, is just repeating anything that comes in on that port. So that's a start. And so now, with that much information, you can find some flags. Here you can send a goodbye instead of sending some other strings. And here, you can start combining it with the string processing, which can get pretty tricky. It's going to send you a number, and you need to add 1 to that number and send it back. And this might sound easy, but the irritating thing, which you might as well begin getting used to, is variable types. You have to keep moving things from one type to another in Python all the time. It seems to be what I spend half my life doing. So you get a string, you're going to have to pick out the numerical part of it, convert it to a number, add 1, and then convert it back into a string to send it off. And so you can, and so I'll just demonstrate some of that here. For example, if I have, let's make another block of code. If I have A equals 15, and then print A, and then print A plus 1. Okay. Then I'm going to get a type error, because 15 is a string, 1, 5. It's not a number. You can't add 1 to it. What you'll have to do is run it through int. to make it an integer. And now you'll be able to print the integer 16. And if you wanted to make it a string again, you can put a string of that mesh. So that's the beginning of it. However, here's another cruel thing. A lot of input and output commands in Python 3 don't want strings, they want byte strings, byte arrays, and that you do this way. You put a B in front of it, it's now an array of bytes. So anyway, you can play with these things, and that's the first bit of challenge here, is to, and then you can consider loops, because we're getting towards brute force attacks, breaking into things. So let's try a loop here. This is actually very nice. In Python, I'm used to really old loops like Fortran. I can do for y in range of 3, print I, and that's going to go 0, 1, 2, up to 3, but not including it. And then you can just set it for C in cat, and it will pick each character out of the string cat. You don't have to tell it to index through. Any kind of list or object you can iterate here, it will iterate through them one by one. So that's handy. And so now, here's one that takes people a little while to figure out. Get two numbers, and you have to either add or subtract them depending on what the verb is. So you're going to have to parse this line of text and get, say, the first letter to tell if it's add or subtract, then find the numbers, turn them into integers, perform the math, and send it back up. And you have to send 5 in a row correct to get the flag. Let me tell you one most frequently asked question. Remember up here, you connect to the server. Connect to the server only once. If you connect to the server 5 times, you'll be doing the first one 5 times and never get the flag. You have to connect once, answer 5 questions before disconnecting. Anyway, that's the next flag down there. And after that, you can start doing non-English characters and non-ASCII encoding. And here you can see some bizarre stuff in Python 3. Took me a while to get used to this. All right, so, oops, that's not the right one. I got to copy it here. When you're in a browser, the command line to the key press to copy often fails. All right, so here I define 41, 42, and FF, and I can print them. And the print is implied.
But those aren't ASCII. What are those? What
That's
are those text numbers?
exact. Well, the first two are ASCII. That's a capital A and that's a B. However, I'm a little concerned that it didn't print them all. Let me try putting an explicit print in here. I shouldn't have to do this. But let's see. A. There we are. Then, all right. So this is an A, this is B. That FF turned into this, and that is the question. What is an FF printed as a single character? That's not ASCII. And the answer is this. You can encode it and print out the hex values, and you will see what they are. And this is where you begin to get a clue how strange this is. If I did it in interactive mode, you see them one at a time. But the point is, the last one is 0xBF. What's going on is the third one is coded as 2 bytes. And this is how Unicode works, which is, by the way, a lot like the IP version 4 address space works. ASCII is retained as usual, 1 byte, and the first half of the possible values used for ASCII, but after that, use 2, 3, and 4 bytes for more and more exotic characters in foreign languages. And so the FF was encoded as BFFF using 2 bytes. So anyway, you can code strange things, and so now you can find Greek letters and you can find a hamburger. Emojis are in Unicode. And they keep adding more. So these are perfectly legitimate characters now. You can put them in your name and everything because they're Unicode, just like anything else. And you can get used to finding them and using them. So anyway.
The Unicode bits, bytes, words?
What's that?
The Unicode bits, bytes, words, what are they?
Well, a Unicode character is from 1 to 4 bytes long.
Bytes, okay.
Yeah, it varies in length.
Okay.
Just like, and so the first byte, you can look at the first byte to decide how many more bytes are coming.
Okay.
Just like IP version 4. Very good. Anyway, so there's a few things to try, and I'll just let you go for a while, then I'll do port scanning in a few minutes, let people work for a bit. I'm going to stop this recording.